Hello, wonderful people of the internet. Welcome back to another episode of Simuleos Panel 2, TS Jaws, Gibbous. Thank you guys so much for coming in. Gibbous, go get dinner. I'll see you in a bit. Oh, I just dropped my pen. And right, yeah, I hope everyone's having a wonderful day. I know a lot of people are, stuck at home. And in fact, I'm hoping that you're stuck at home because at this point, if you're not socially distancing, it's kind of probably hurting people's health. That said, I know that a lot of people are probably struggling to socially interact with people, so feel free to chat in the stream, do whatever you want to do, hang out, I'm hoping that these next 2 hours are just 2 hours to hang out, chill, talk about, our mutual love for algorithms and computer science and all this kind of stuff. And yeah, there is one thing I want to show you guys that is absolutely insane that I kind of want to try. What is it? Vim Cubed, I think is what it's called. There it is. So this is, if you haven't seen it before, which I'd be surprised if you have, because I think I only saw it today. This is a three-dimensional. Yeah, let me do view image. Scroll in a bit. It's Vim, but 3D. So for all those people in chat who've been constantly wanting a higher dimensional text editor, oh boy, this is it. I'm sure we can modify the source code for VI. Ooh. That would be a beautiful thing to do. Oh, I want to do it so badly. I should totally do that. Let me check the source code. It's probably relatively straightforward. Background. See, vim3.nim. They should be just calling VI, right? Somewhere. They have to be, right? GLFW window. I mean, just use an OpenGL under the scenes. Where are they calling VI? I mean, it seems like a relatively straightforward program. Okay, I'm very interested in doing that, actually. Because of all the things to do. Honestly, there's a number of these little small things that I want to do. Like, for example, changing this to BVI, just because I feel like doing it. And, okay, so hear me out. I've been thinking, okay, this is kind of... Okay, let me start at the start. So there's this website called youtube.com. Some of you guys may have heard of it before. It's a website where people post videos. You can tell what videos I like to watch, apparently, because, right, these are apparently the videos that YouTube is recommending to me. As you guys know, I have a channel on this called User LEIOSOS. I'm going to be putting videos on this channel from now on. I have been in the past, as you can see from the fact that I have 63,000 subscribers, but I will be putting videos up there in the near future. I've been thinking about... See, I don't work very well under time constraints for video production. I don't. But that's because the videos that I have been making recently take a lot of effort. Not necessarily in the video production part, but the video production plus the algorithm archive content, plus learning the algorithms, all this kind of stuff. What I've been thinking about doing is, instead of focusing on this giant project to do every month or whatever, what if I still do that project every month? We get out the algorithm archive content when we get out the algorithm archive content, but we do smaller things as well. Like, for example, changing this to be VI cubed or something like that. Or, the Arch install speedrun or all this kind of stuff that we've done before, but like, I don't have content for, you know what I mean? And then I was also thinking about doing some sort of content that's something like Casey Neistat style vlog at some point. Like, sometimes I've got these... I used to have this series, this ongoing series, which I guess I can show you here. Let me see if I can. You guys shouldn't see my screen. Let me see. Go to YouTube Studio, and I'm going to make sure I don't show you guys anything I'm not allowed to show you guys. I should just be able to go to my videos, and it should be that you can see... Yep, nothing but my videos. Does it... I need to make sure you can't see how much I make on every video, because that's not allowed. But I think... Oh, why don't I just go to my channel? I know how to do this. Oh, no, that won't work. Will it work? Let me check. I'm sorry, guys. I know it says I'm doing something embarrassing and you can't see, but I think you can still hear me. If you can't, then I'm doing something miserably wrong. Just scroll down. Keep scrolling. Oh, boy. Back in the day. Okay. Let me show this to you guys now. I think this is fine. Okay, long time ago, in a YouTube far far away, I used to make videos, 3 videos a week. A video on Tuesday, a video on Thursday, and a video on Tuesday, Friday, and Sunday. Those are the upload days. Tuesday would be a science video. Tuesday would be a science video. Thursday would be an explanation of said science video. And Sunday would be like kind of a vlog style, just like chat in front of the camera type of thing. So here's kind of the history of my YouTube channel as we've had it before. Let me go ahead, never mind, I can't make stir fry because my sister's using the pan to make a crepe. So I'll have to wait until she finishes doing that and then clean the pan. Let's see. There should be a view as random thing. What do you mean by view as random? You guys can't see me now, right? Okay, good. You sir are the only person I've seen besides me that uses IRSSI to show chat on stream. Dude, it's the best way. Like, there's no better way to show chat on stream. But here, let me just show you my YouTube content. So, Gaussian elimination, which literally came out a year and a few months ago, was the last real video I made for my channel. From there, I've made like really stupid other videos, like this one where I just showed that there was an issue with Guild Wars. So I've got basically I couldn't use it with my tablet. For those of you guys who don't know, I use a tablet for my mouse all the time now, just because my regular mouse broke, and why not? I use the tablet all the time on stream anyway. So here's all my videos that you've seen recently. So here's what is an eigenvector, which is probably the video that kicked off the current era, I would say, of my channel. Maxwell's Demon was me kind of broaching that topic, but now let me just kind of go down a bit. So these are some streams that didn't get properly put into the Simuleos YouTube channel. By the way, I need to export my stream today. I forgot to do that. Yep. So let me just put that down. I need to do that after stream, otherwise I'm gonna forget. Cool. Now let me go further back. So here we're talking about the invisible lens that turned into something. Keep going down, keep going down, keep going down, and here we are, old cringy YouTube. I removed all these videos. These videos are no longer on my channel. But yeah, I put out a large number of videos. Look at all these videos, like 100 videos. Well, maybe not 100, but a large number of videos. Here's an old Easter video back then. Yeah, just me talking to the camera. And I don't want to do that anymore. I don't want to talk to the camera anymore. But what I do want to do is I want to kind of do more of these videos here. So these were Idea Factory videos. My stream kind of turned into these. The idea behind these videos was that I would just talk about an idea that I had. And yeah, go from there. That was kind of the whole idea of it. And I wanted to kind of present them in more of like a Casey Neistat style vlog or something like that. So I was thinking, why don't we have the usual programming content, maybe do smaller projects as well. Basically what I'm trying to say is I want to go back to doing regular uploads on YouTube. I've just, I didn't want to do it for a while, but now I'm kind of into it again, Why can we see the liquid nitrogen video? Oh, the problem was all my science videos were dumb. So, okay, the reason why I don't show these videos anymore is simply because I didn't know who these videos were for, right? I was just making videos because I was very, very bad at socially interacting, and I kind of wanted a way to interact with people. Like, I wanted to find out how to do this. I wanted to become better at public speaking. And so what I did is I started making videos. A lot of them are just dumb. All of them are dumb. But I got better at interacting with people. This helped me overcome my social insecurity, And I made more and more videos. And the truth is, I just stopped making them in this format because they weren't good videos. And the way I see it is when people come to my channel, they should expect a certain quality to the videos that I create. And you're right, I'm not going to go out and say that all of the videos I've created recently are fantastic quality. Some of them aren't that great. But what I will say is I stand by every single video I have on my current channel. I don't stand by these videos down there anymore. So it's more or less a branding issue, right? Like, yeah, I these videos were great for a time, but I just don't think it's good to keep on anymore. I think it's if your brand changes, I don't think you should show these videos. I don't think these videos are consistent with my current brand. That's why. I'm not a computer scientist, but I want to design specific algorithm. It's about how many ways there are to stack numbers with the specific rules. How should I go about finding algorithms for similar problems? I obviously looked into the algorithm archive, but I'm looking for a very specific thing and have no clue how to find such things. What kind of number stacking are you talking about? Right, depth first would probably work for if you have like a tree or something like that. Or like graph or something that you're traversing through. It depends on what you mean by stack. Right. Anyway, point is, Vsauce started out as a gaming, let's look at memes channel. Right. The thing is, I respect Vsauce's philosophy here. Vsauce has this idea. So he was asked a while ago why he keeps all of his old videos up. And he's like, well, it's like a history of Vsauce type of thing. And you can't get rid of your history just by deleting it. I 100% agree with that sentiment. On the other hand, there are some things that I said in these videos that I simply do not agree with anymore. So like, for example, I made some claims here. There was a video I made about the NSA and Linux, right? Specifically because people were claiming that this is back when Edward Snowden came out and all this kind of stuff. And people were making claims that were false at the time. And so I started talking a bit about how HPC architecture has been built up and how Linux is very useful in this space for a number of reasons. It's very good with security for these reasons, all this kind of stuff. But some of the statements I made in that particular video are no longer correct. And people would come in and they would clarify that. And I'm like, well, okay, that was the current architecture works this way, but the architecture I was talking about five years ago didn't, right? And so it's kind of like some of that stuff's wrong. And so now I didn't want that anymore. And then here was a video all about supercomputer and gaming. And I was explaining why you can't use a supercomputer to play your favorite video game, right? And again, some of this is wrong now, because nowadays, back then I was saying that GPUs weren't a big part of supercomputing, and now they are, and, computer memory, just a lot of, like, then I was talking about hard drives, but now SSDs are a big thing, So there's just a lot of things that just have changed, and I don't think I could talk about much anymore, or I don't think are correct anymore. The result is on the order of 10 to the 20. So brute force searching won't work. I'm looking for neat ways to simplify it without looking at individual numbers. 10 to the 20. 10 to the 20 numbers is a huge number. 10 to the 20 values is a huge number to keep anywhere. I'm not sure that's going to be hard. Okay, I don't know how you're going to do that. It is very difficult. I can't think of anything. There has to be some sort of, and you definitely need math, no doubt. There's some sort of data compression that you're going to have to do, or some sort of information culling so you don't look at it all. I'm not sure. This is actually, that's surprisingly larger than I was expecting, Let's see. Okay. Me, a Googleology enthusiast. Okay, right. I know Googleplexes are larger. Anyway, okay, so my point was, I do want to start making regular YouTube content again. And there are a number of reasons for this. So let me also show you one more thing. Let me just go to twitter.com. And let me look up Smarter Every Day. Okay, so everyone knows Smarter Every Day, right? Right. Super cool guy. Big fan of him. He's genuinely one of the most inspirational people I've met. He is doing stuff for coronavirus. He's genuinely doing his best to create masks, to do stuff to help people fight coronavirus. Like he's able. His job is flexible enough. He's essentially an independent researcher, right? His job is flexible enough that he can do what he wants to do. If he wants to find a way to help people with coronavirus, he can. And he will, because that's his job. Or that's part of his job, Same thing with Grant from 3 Blue and Brown. He made a video on stuff that, coronavirus stuff. It's just, they have the freedom to study and work with what they want to do. Or like, you know what I mean? Like they have the freedom to do what they feel is best to do. And I kind of feel like if I could just do that somehow, if I could get to that stage where I could, I could be an independent researcher, study what I want to study. And I just think that's honestly like a dream job for me. And it's been a dream job for a while. So I guess my point is I can see how to do that with YouTube and I kind of want to try it, Basically, how many different ways are there to make a rectangle of numbers, but rectangles are considered the same if you have to switch... How many different ways are there to make a rectangle of numbers, but rectangles are considered the same if you just have to switch rows and columns. I'm also not quite sure what you're talking about here. So how many different ways are there to make a rectangle of numbers? A rectangle of numbers. So that's what is a rectangle of numbers? First question. But rectangles are considered the same if you just have to switch rows and columns. Are you just saying that you have a bunch of rectangles of different lengths? Like a matrix. Okay. So you have a matrix of elements that you... So it's like an n by m matrix, right? So let me see if I got this right. Let me open up Zernal. PP. Let's move that over here. Superroot is asking about unique pairs of numbers that multiply together to equal the target. Are you talking about the transpose operation? Oh, we've all read this to be different than... I think all of us were equally confused by that. I'm sure it's a super interesting problem, though. If you have 10 to the 20 numbers, I mean, like row switching rows. Row switching rows. Are you talking about, like, okay, so you have a matrix, n by m, we'll say n by m matrix. So we'll just draw a giant square. Ooh, okay, let's try that one again. We'll draw a giant square here. We'll put some lines in here. So we'll have a line here, and here, and here, and here. So in this case, n is equal to m is equal to 3. And you're saying you want to switch this row and that row? Is this what we're talking about? Or are we switching this, is my question. Are we flipping all the rows and columns? They're saying that the rows and columns are unordered. Right, so then is it just in a huge unordered list? Hey, Trash Talk, I don't know if I said that. And hey to Cropeb too. I guess I didn't technically say hi when you said hi. Okay, well, regardless, that's my philosophy on YouTube from now on. I do genuinely want to make more content, and I think I will. Because, yeah, I am kind of averse to making video content, and I've mentioned a lot of times that it doesn't necessarily make me happy. On the other hand, I am convinced now that it's a good thing to do for a number of different reasons. Also, why am I not erasing everything? 1 second. Come on. I'm just convinced it's a good idea to do moving forward. Okay. Okay, come on. Erase. Erase. This is taking a lot longer than I expected. And for some reason, it's just not erasing everything. Okay. So, right, what are we doing today? Today, we are going to be focusing on finishing up the animation that we started 2 days ago for Gauss's Easter algorithm. When the animation is done, I have one more image to create, and then the chapter is ready to go. I have most of the script ready to go. So the video should be, I'm hoping, I should have all of the elements for the video, including all the voice recording and video elements of it, ready to go by Thursday. And then I was hoping on Friday to do a stream related to just video editing stream. That's what I was shooting for, you know? So that's kind of what I'm hoping for. So let's go ahead and draw or talk about what we're going to be doing today. So right now we're going to be talking about Easter. And if you guys haven't been here before, you know there's a lot of really cool things about Easter. In particular, I want to talk about calculating the date of Easter, which is one of the most computationally infeasible problems, I think, in history, right? It's one of those problems that fundamentally push the boundary of human knowledge, even though it seems rather trivial. Easter is always held on the Sunday after. The Sunday after. Try that one again. Sunday after the first full moon of spring. Okay. As such, it requires us to keep in mind the solar calendar and the lunar calendar. So here's the sun, the earth, and then the moon will be this guy over here. So in order to do this, we need to keep into account that the earth revolves around the sun every 365 days. And the moon revolves around the earth basically every 30 days. It's like 29.5 days or something like that. The fact that these 29.5 is not like a multiple in any way, or rather, yeah, 29.5 is not a multiple of 365 in any way, means that these two calendar systems are out of sync. And because they're out of sync, there's basically a 19-year cycle until they sync up again, right? So here, I just want to do a simple visualization of this 19-year cycle. That's kind of what we're focusing on. I'll show you what we have so far, and we'll hopefully finish up this animation today. That's the goal of today's episode. Once the animation is done, then I just have one more thing to visualize, which I can do tomorrow. And then the day after that is just, well, tomorrow, not only am I going to get the last thing visualized, I'm hopefully also going to be going through the algorithm archive chapter with you guys so we can put up a pull request. And that should be everything for the algorithm archive. The rest is just getting the YouTube video ready to go. My goal is to get it all edited up by Friday evening so that on my trip back to Alabama this weekend, on my trip back to Alabama this weekend, I can set it to automatically upload probably Sunday morning or something like that. So we'll see how that goes. Okay, so I'm going to go ahead and CD into projects, Simuleos, and then we're going to go into, what am I looking for? Computers here. We're going to CD into projects, Simuleos, and computers here. And let me see if I have it in my history. I do, luckily enough. I'm going to open up a few more terminals just because, you know me, I like terminals. If there's one thing I like, it's terminals. Let me move this over here. This is going to be hidden under my face just because I feel like hiding it under my face. And I will also open up another terminal back here just in case we need it, which will be a size medium. And let's just make it big. There. Okay. So this should be compiled, and if I run /Gauss visualization, should create a video that I can play over here with mpv temp video.mp4. Right, so this is the animation we have so far, and let me just do loop 0. Okay, so here's the animation we have so far. Let me start at the start. So here we have the sun, the earth, and the moon all being created, right? And then you see the earth rotating around with the moon going around it, right? Look, I know a lot of people have made fun of this animation for a number of reasons, and I realize, yes, the orbit should be elliptical. There's a lot of other things that should be happening. I get that. What I wanted to show was simply that if you look at this animation, we have, again, the Earth's starting location, the moon's starting location, and then the Earth, as it moves around, stops here and here. So this position right here is when the moon has gone through 12 lunar months. However, the Earth is now out of phase. When the Earth meets, the moon is out of phase, right? So the whole point of this animation is showing that there is a desynchronization between the Earth and the moon. And I just hit the microphone. I apologize if that was loud. So yeah, let me know, or rather, so that's kind of the point of the animation. That's kind of where we're at. So I've got to do a few things with this guy. I've got to kind of discolor the Earth and the moon and stuff like that in the background. And I've got to figure out the exact time it takes for the Earth and the moon to hit 12 lunar months. The other thing I have to visualize is I want to draw like an arrow, basically from Earth to Earth and moon to moon, so I can show the difference in phase there. So that's what we kind of need to show. That's kind of the animation as we're at right now. Let me go ahead and catch up on chat. Let's see. I figured out why GAG2 is 7. The GAG prefix means that the number to use it as both arguments for the Ackermann functions, thus GAG2 is A227. Different ways to fill the matrix without counting equivalent matrices. Additionally, MAG recursive applies to GAG bag. I have no idea what we're talking about. What's the limiting factor? Some of the elements should stay the same. No just possibilities. But there are an infinite amount. Also, numbers can go up to 9 or something. So 0 to 9 per entry. Next, I will figure out why 55 is Fibonacci. It's not Fibonacci. It's Fibonacci because it's the 10th Fibonacci number. Huh. Okay. What are you talking about? What are you counting up on? Is this Googleology? Googleology? Is that what that is? Googleology? Okay, maybe I didn't understand what Googleology was. Is there an area of math about how many ways there are to do a thing? I don't know where to look at all. I'm not sure I can figure it out on my own. I don't know. Maybe someone in the chat can help. Let's see. Thanks, I'll Google that. It's also not even known if Sasquatch can be proven to exist according to Googleology Wiki. What is Google? Okay, I fundamentally am misunderstanding what Googleology is. I thought this was a study of very large numbers. Yeah, it is large numbers. How does this have anything to do with Sasquatch? Um, I'm talking about Googleology studying large numbers. There has to be a definition. So not only is the Earth flat, the sun and moon are flat too, and there are 2 Earths and 2 moons. I'm so sorry. I realize it could be kind of confusing, but hey. Let's see. Comment works 3 moons. For real, this is very fascinating. Hey, I'm glad you're here. If you have any questions, comments, concerns, anything like that, feel free to let me know, and I will totally address them as soon as I see them in chat. Again, I'm not trying to... I'm a bit tired today, so I'm not going to be giving the cleanest definitions or answers or anything like that, but I promise I'll do my best to answer whatever you guys ask. It's just, I'm very, very tired today. So we'll see how far we get. Right, so I'm just going to put this in the upper corner over here. Yeah, something like that'll do. And let me grab this and make it a bit smaller. Maybe something like that. Right. Up. Oh, let's drop this down a bit too. There. Okay. So yeah, we should be ready to get started. Let's go ahead and go into VI Gauss Easter. Not JL, I'm sorry. Should be Gauss visualization. .cpp. Nice. Now, Zadison sent me something yesterday, just after stream, or 2 days ago, just after stream. I just haven't been able to look at it yet because I'm dead inside. And let's see. I'm gonna take a look at that really quick. Except I don't know how to use Discord, so yeah. How do I look at personal chats? Okay. Right. There it is. Got it. Here we are. Okay. So what he's saying is that we need to update the moon frequency and stuff like that. So let's go down here. So basically the way I have this is we have an Earth frequency and then a moon frequency. We're using SDL2 and OpenGL. No, we are using just Cairo. Cairo is a, well, it's our own visualization library known as GathVL. Here, I can show you guys that. But it's using Cairo underneath. GitHub.com. And I think I can just go to GathVL. Okay. And then algorithm archivists. Here. So this is what we're using. It's using Cairo underneath. You might be asking, hey, why aren't you using OpenGL and all that kind of stuff? Truth is, we did spend a significant amount of time coding up our own OpenGL based library to do these types of visualizations. But in the end, it's just, it just took too long, you know? We spent a long time trying to get it to work, and I ended up just wasting months just trying to get it to work. And I didn't have the same functionality as with Cairo, and because for the most part, I'm just creating static images, and we don't really need the dynamic nature of OpenGL. You know, that is to say, we don't need people to click, we don't need people to interact. And really, we just want a video out in the end. FFmpeg plus Cairo was honestly probably the best way to go. So that's kind of where I'm at with that. I do 100% admit. Let's see, new lesser public. Oh, actually, does that screw us over? Oh no, it's a new lesser general public license. Okay, cool. So that's where we're at. If you don't want to create your own rasterizer, right? So that was the issue, right? Like I fully admit that if I was pro enough, OpenGL would be probably the best solution here, or even Vulkan. Happy Little Rat usually comes into the chat and he talks a lot about how we should be using Vulkan, but it's just not. I would rather get something done than spend hours just trying to build a program, right? By the way, Floating Man, thank you so much for following. Really appreciate it. My point is to say, a lot of streamers on Twitch, they do specifically, they create a product, right? They're creating a video game. They're creating a lot of this type of stuff. There are a lot of people here who know OpenGL, and they know how to make these types of programs. But that's not me. That's not our project. Our project is the algorithm archive, and being bogged down by all this stuff isn't necessarily something I want to do right now when I'm busy with other things as well. I opened the wrong wiki. What's the other wiki? Oh, this is large numbers fandom. Is this the wiki you wanted me to go to? What's the difference between this wiki and that wiki? I mean, the other one's large. The other one is largenumbers.fandom.com, whereas this is googology.wikia.org. Or is there another one? Is there some other wiki that I unless your stack is Java, in which case your stack is bad and you are bad. Let me see. What do we have here? I'm not one of those people that craps over your stack if it optimizes for at least one variable at a time. Wait, I missed a lot. Cover is fine if you don't want to create your own rasterizer. Let's see. I'm not the one of those people that craps on your stack if it optimizes for at least one variable time. Oh, I lost my bioinformatics job yesterday because of... Dude, that sucks so much. I'm really sorry. The downside of working in industry rather than research. Dude, I'm so sorry about that. It just sucks that, someone... I don't know. I don't know what to say. I'm sorry, man. It's bugging me. Could you fix it? Unless your stack is Java, in which case your stack is bad and you are bad. Did you use OpenGL for your research next to CUDA? No, I honestly, no, I never used OpenGL for that type of thing because it was never useful for me. CUDA was always computation, which is fine. But for visualization, I mean, you didn't really need anything fancy. You could get away with just ParaView or something like that, You open the one that I linked above in the message you did not read. I just can't. Oh, I didn't see that link. Sorry. I'm trying to keep up with chat. I'm sorry about that. Right, NewPlot is literally fine. Oh, so this is now... Yeah, this is the same wiki I had up earlier. I watched a look into Dutch hospital. It's like watching Apollo 13. Stone cold professionalism in the face of crisis. Yeah. If you were using OpenGL for CUDA, you'd be using either OpenMP or OpenCL. Right. So what I would be doing if I was using OpenGL is I'd be using OpenGL interoperability with CUDA. OpenGL would not be used for computation, but I'd be using it for visualization on the same graphics card with the computation. That's what I'd be doing. I pinged you even. I don't see pings very well now. I have another chat up on my side screen because I have to look at Zadison's chat. So I'm not really able to see everything right now. Normally I would be able to see it because I have stream chat on the side as well, but I'm sorry. If you want the name to be highlighted, don't @Simuleos. Just do Simuleos. So if you just say Simuleos, this will highlight the message. But if you do @Simuleos, equals no highlight. So, let's see. Today I tried to :WQ my IRC client. Dude, I've done it so many times. This isn't Vim. Yeah. Should put Googology resources in the off-topic channel on Discord for later reference. Yeah, feel free to do so. As far as OpenCL and stuff like that, we've had long discussions about the viability of OpenCL in the HPC ecosystem and all this kind of stuff. But, well, okay, if someone else, maybe I can do it here. Can I highlight myself? So that should be yellow. So see how it's yellow over here? That's what I meant. All right, see you, Crop Ep. Have a wonderful evening. Okay, let's actually get some work done because I've just been chatting, and yeah, I feel like we should get some work done. Things are going well, I guess. But yeah, if anybody is having any trouble with coronavirus stuff, and you guys just want to chat and hang out, this is the place. Just kind of do so. I feel like there's a lot of I don't know. There's just a lot of crap happening in the world right now. Like what Trash Talk was saying earlier with the stone cold professionalism and stuff like that. I'm doing my best to be open and honest and all this kind of stuff. And I think just having a group of people to talk to about nerdy things is one of the best things that we can do. About this time. Just hang out, chat, do creative things together. That's kind of where I'm at. Hi there. Have been going through a chemistry PDF, a lot of stupid people. I feel like if you go through the history of the universe, or the history of Earth at least, there are a large number of stupid people. I feel like the world is built upon stupid people, Doctors and nurses are the true superheroes. Yeah, it's actually my sister's birthday today, and she is a nurse. She just started nursing this year, and it's just a rough year to start nursing, Would you consider doing a COVID-19 simulation video or something COVID-19 related? I thought about it. So a long time ago, we did a video. Let me see if I still have anything. Oh gosh, can I type? Apparently not. Epidemic? Where is it? I thought it'd be under epidemic algorithm, but maybe not. Maybe it's under viral video, actually. Yeah, there we go. What's our out.mpv4? mpv out.mp4? What is this guy? Ah, right. We did an epidemic algorithm. Whoa, hello there. We did an epidemic algorithm a while ago. Right. Yep. So this is our epidemic algorithm. We didn't finish the visualization here. Gosh, why was it so slow? Holy cow. Jeez. That's super slow. Maybe if I control C out of this one. And let's loop this one as well. Let's do loop 0. And I'll just full screen that one. Long time ago, we made a visualization of an epidemic algorithm, specifically a push-pull network about infected people. We had a very low rate of infection. The thing is, I don't want to confuse people. This animation is crap, like absolute garbage. This is not the animation we'd show in the video. I'm just saying that we have the backbone if we wanted to build something like that. These are all different people that all start off at different locations and then move around. This never turned into a video. I mean, most of the things I've made never turned into videos. And I could push this out. We could turn this into a video. We could turn it into an algorithm archive article where we talk about epidemic algorithms. We could do that. The problem is I feel like it would confuse people because this isn't related to the typical model that people talk about. This isn't related to the SEIR model. It's not related to that at all. This is fundamental before that, right? Like this is talking about, this isn't talking about how to project, you know, it's not about how to project where we'll be in a month or something like that. This has nothing to do with that. This has to do with the simulation of people getting infected, not the trajectory of them getting infected, right? Like we're not talking about, I hope this is kind of making sense, right? So this model here will say that you have susceptible people, exposed people, infected people, and resistant people, right? And so you have some sort of model where you have an exponentially growing number of infected people and you can trace a trajectory with time. And that's what people care about, you know? They care about how long they're going to have to deal with the coronavirus. That's not what that's not what I'd be talking about in this video at all. I'd be talking about push-pull networks. I'd be talking about epidemic algorithms that simulate the movement of the virus across a network. But, I'm sorry, I wouldn't talk about the rate of growth, which is what people care about. So I didn't want to confuse people. I didn't want people to go to my video and then be like, oh, I understand everything about epidemic algorithms, because an epidemic algorithm is very different than an SEIR model, right? Super different, right? And we can track this with the epidemic method or with the epidemic algorithms, but I just feel like it's too convoluted to put into a single video. I don't know. We'll see. Have you considered libffmpeg so that you render straight to video for your animations? We're actually doing that as it is. I'm gonna get dinner and such now. See you, Gibbous. Have a wonderful time eating dinner. I wish her a happy birthday. Yeah, I mean, yeah, we'll see how it goes. I'm sure she's very busy. Sometimes the idiots are right, though. Yeah. Anyway, so that's kind of where I'm at. We've done videos before, or we've talked about this before. I could definitely turn this into a video, but it's up to you guys. Like, is this something that you guys feel like we should do? Or is this something that we should just kind of leave in the background because it would be too confusing for people? I don't know. I'm just kind of lost. Yeah. To be fair, this particular one, I wanted to do this in a collaboration with Draw Curiosity back in the day, where we talked about viral videos and what it takes to get a video to become viral. It's the same method, actually. You use an epidemic algorithm, and then you do, I think we used affinity propagation at the time to do some sort of clustering, and it's not a difficult method. It's actually rather straightforward. I don't know. This is where I'm at. The other issue is I do want to do something for COVID-19. I want to somehow help out. I just don't know how to do that right now. You know, I feel like the best I can do is just like help people out who are staying at home and, you know, entertain them for a bit and maybe teach them something. I feel like I don't know. It's just tough. I'm sorry about rambling about this. Anyway, let's go over here. Let's go back and let's start talking a bit more about Easter. So we're gonna simulate CD into Computus. But yeah, that was another reason why I wanted to make more videos frequently and stuff like that, because I just kind of want to, I don't know. I feel like a lot of people will probably get depressed if they're cooped at home, you know, all day. And I figure just having maybe a video a week or something like that, you know, that might be a bit more motivating, could be potentially useful for a large number of people. I don't know. We'll see. Okay. Let's do VI Gauss visualization .cpp. And Zadison, I'm glad you're here. I'm just now going to implement the frequencies and stuff that you gave me the other day. I still don't understand why we'd be using a sidereal year instead of a synodic, or a sidereal month instead of a synodic month. That's what I don't understand, because the synodic month should be the one. Like, I don't understand why we would use that. So let me just yank paste, grab this, and let's implement what you've got and see if that works. This is still with the magic number that we had before. So I'm also going to yank and paste this and comment this out. Oh. And then let's just do plus 50 like before. Okay. So let's see. You have the moon frequency is going to be equal to the earth frequency. Do I have an earth frequency? I must have it. Oh, it's up here. So you say the moon frequency is equal to the earth frequency times 365 divided by 27.32. So I did earth frequency times 354 times 12 over 300. So this is, yeah, okay, I see why this would be incorrect. So what we actually want here is 365. Why would we multiply? So the earth frequency is going to be, yeah. So we do 365 divided by, and you're saying the sidereal frequency, which is 27.32. Sidereal is the global coordinate system. Synodic is in the Earth relative coordinate system. See, that's what I thought it was the other way around. That was why I was confused. So the lunar, right? So I'm so so sidereal is the moon's period, the period of the moon's orbit as defined with respect to the celestial sphere of apparently fixed stars. The synodic is the average period of the moon's orbit with respect to the line joining the sun and Earth. So I thought that's the one that we wanted. The fixed stars bit clued me into the problem. Right, so I'm just, okay. So my understanding was that we wanted it to be, no, it should be synodic. We should definitely be looking for synodic, because a new moon is defined. Right, let me just, the line mentioned in synodic rotates in relation to the Earth's position. Right, that's what I thought we wanted. Journal new page 4. So we have the sun here, and then we have the Earth here, and then we have the moon here, right? So this would be a new moon, because the Earth completely covers that. So when the Earth is here, this would be a new moon, right? So that's why I thought we wanted synodic, because we want it to be that, we want this line to change. The rotation in relation to that line has to be included in the theta used. So the rotation in relation, oh, right, yep, that's what we want then. Yep. So we want that one then. So let's do that then. The lunar year frames. Let's just DD here. Nice. So let's try that out. So this should be the moon frequency. So I'm reading your thing right now. Earth frequency times 365 times 12. So we'll do 365 times 12 divided by 354. Which again, 365 is the number of days in the solar year. 354 is the number of days in the lunar year, so 12 lunar months. And then down here we do the moon frequency is going to be minus equals the moon frequency times time step plus, or is it going to be minus? Oh, it's minus equals. So yes, that should be a plus. The moon frequency. What second? Minus equals the Earth frequency. So can't we just do Earth theta? Let's try that. Then we have the plus 50. So we're going to compile this guy. See what we got here. Crap. I misspelled Earth. I misspelled Earth again. Okay, let's give it a go. Gauss visualization. And let's see what that looks like. Okay. Give it just a second. And then we should have... Oh boy. That's it. That's our moon. They're aliasing errors to make it look like, you know, first there's one moon. Wait, let it go again. So first there's one moon. Now it looks like there's 5, 4, 3, 5, 2. Oh boy, this is wonderful. Whatever I did was wrong. Okay, let's see, what do we have here? Which is why I suggested adding the Earth delta to the Moon delta as well as an alternate solution. Okay. That was wrong. Okay, so let's try the other one then. Moon frequency times time step, Earth frequency times time step. Oh, because I'm putting the whole Earth... Let's put this in correctly then. Earth frequency times time step. Let's do that correctly. Yeah, I shouldn't have gotten ahead of myself. Try that again. And let's see what we got. Yeah, I don't have motion blur. That's one big thing that I wish I had. Okay, so here we have everything going around. That should do it. I think this is right. This is the visualization we want. Come on. And yeah, okay, I'll take it. That's it. That's it. That's what I want. Bam, look at that. Okay, so we have the Earth, the Sun, and the Moon. They're moving. And then, you know, they're doing their thing. You know, just thinging it around. I don't know what I'm saying. And they stop. Perfect. Nice. So now I just need to draw an arc, and then appropriately color these guys. Right. So the idea is that we have. I need to think about this a bit more, but I think we're there. I can make the visualization I want. Cool. There we go. Zadison is officially the smartest person on stream, which sounds like a really big how do I put this? Like a really big, sounds like a really good thing, but I mean, you haven't seen the people on stream, so you know. Might need to implement motion blur. Nailed it. So either use a sidereal month or the global theta. Okay. So now the last thing we need to do, well, there's one more thing we have to do, but that's coloring it. I'm not too worried about that because that's easy. But what I do need to do is I need to create a new array. Or rather, I need to create a new... How do I put this? I need to basically create two different vectors of points. One vector of points is going to be from the old Earth to the new Earth, and the other vector of points is going to be from the old moon to the new moon. So that's what we need to keep into account. So I'm going to just... I guess I'm going to create a theta vector, and we'll just go from there. This should be doable. Unfortunately, it means that we're going to have to push back a bunch of values, which isn't great on memory, but I really apparently don't care about memory. So let's do std vector, and we'll say, what are we going to call this? Moon, theta, I guess. Crap. Is the audio and video out of sync? Let me check about if that's out of sync. I don't know. I can't do anything about that. I'm just going to have to turn off my video. Out of sync. I don't know. I can't do anything about that. I'm just going to have to turn off my video. All right, turning off the video. Let's go. Sorry about that, guys. How do I do that? Which scene is this? Scene 2-2? Yep, there we go. Okay, so I just won't do a video for the rest of the day. Sorry about that. I literally, every single day before stream, I specifically spend like 10 minutes syncing my audio and video. Just because I can't. There's no way to keep them in sync. So, okay, cool. cool. So we'll just do without video today. That's perfectly fine. Yeah, and I guess I also can't put this on YouTube either. That sucks so much. But it's okay. Yep. Graphics experience finally paid off. Yeah. Okay. So let's see. Is buffering checked in the web? There's nothing I can do about that. Like here, let me just go to scene 2. And if I go to video capture device, I go here. It doesn't matter if buffering is on or off. Like if I turn buffering off, then it's actually maybe it works. Let's see what happens. Crap. Did I save that? Okay. Yeah, maybe it works. I don't know. I've got a feeling it doesn't. Yeah, the problem is that my client down here, I also have to offset this. So this is offset by like 200 milliseconds or something like that. And I just have to guess. Like every day I have to change the offset. So, okay. So, but now I think the FPS is off. Right? Yeah, it's a bit off. It's fine. I don't care. Okay, let me move back here. By the way, to Lord, thank you so much for following. Really appreciate it. Okay. Let me check over here as well. Okay, cool. Sorry, I just have a bunch of notifications to look at. I need to not have a side screen, but then every time I don't have a side screen, I get a whole bunch of messages from work, and then I get in trouble. So, so we'll say I'm just going to create 2 different arrays, moon thetas and earth thetas. I don't care. This is what I'm doing. I know this is a dumb way to do it. This is just what I'm doing. Okay, so we have the earth theta and we have the moon theta. And what I want to do is, if I is greater than lunar year frames, what do I want to do? If I is greater than lunar year frames, I want to put all of those thetas. Yes. Where are we? And this is equal to 1. And down here, I'm going to create a new if statement saying that if, what am I looking for? Indices is equal to 1. Right? So now we do this. I'm just going to push back these 2 arrays with a bunch of thetas. So we should be able to, yeah, we should be able to do earth thetas dot pushback. I realize this is super slow, but it's just what I'm doing. Sorry about that, guys. And I will do moon thetas. It's going to be moon. It's not going to be that bad. Okay, so this should give us an array of SQ vector missing template argument. Oh, right, because I forgot how to do vectors. So this should be doubles. Something like that. Write this, and that should compile. Right. Okay. So, why was the smiley so hard? Okay. So now we have the earth thetas and the moon thetas. And what I need to do is I now need to create 2 new arrays. 2 new lines that are going to draw from the 2 earths and the 2 moons. So we have the initial moon position and we have the initial earth position. So let's just go ahead and drawing the line for the earths. Something like this. How are we going to do this? So we need to create a line first. So let's go to CD projects, gathvl, ls. There's probably a way to do an arc. I bet there's a way to do an arc. Yeah, he's got an arc in here. So maybe that's what we need to do. An arc between one theta and another theta. Let's see what we can do. Arc. I feel like I've drawn an arc before. Yeah, no cat, thank you so much for following. Really appreciate it. Let's see what I'm going to do here. So let's go to vi viz test.cpp. Let's look for arc. There is no arc. Okay. Did I draw an arc somewhere else? CD simuleos, leios curve, ls here, vi scow.cpp. Let's look for arc. There is an arc here. Okay, cool. So I think, let me see what this visualization looked like. I'm just going to do /main. And what does this visualization look like? I'm sure I put, where did this go? Ah, there we go. Right, that's exactly what I want. So a long time ago, I tried to remake my logo, with Gaspiel. I didn't have time to finish everything, so I basically just made an arc, like part of my logo. I need to finish it. There's a lot more to be done. But one day we'll have this fully animated and beautiful and all that kind of stuff. We're not there yet. Okay, so that means we can take a look at this arc thing, and we don't need to keep a list of indices. We only need to keep the initial theta and the end theta. Ah, crap. So let's go ahead and keep those two thetas. So we'll say, oh, what are we going to call it? So we'll call it moon theta. Moon theta, I guess, or origin. Moon theta start. And then moon, let's do an array of 2. Double moon theta 2. And earth thetas 2. Wonderful notation here. DD here, and what I'm going to do is, at this point in time, I'm going to go ahead and save. I'm going to save the second value. So let's see, what's our initial theta? Where's our theta? Moon theta and earth theta are both m pi over 4. Actually, that means I only need to keep, since we know these initial values. I'm sorry, guys. Let's just do double. I don't know what to call these guys. So we're going to say moon thetas. And we're just going to say 2 is going to be equal to, and I think I can do this. Unless I don't remember C++ at all, which is also, maybe true. It's probably true, actually. Okay, so let's do that. So where do we use moon theta? Moon theta. Oh, let's change this to moon thetas. It's fine. Doesn't matter. So here we're just going to change this to 0 and that to 0. And then let's look for where we also use it here. There and there. And I think that's it for moon thetas. So let's update the earth thetas. Okay. Earth theta. And let's also add a 0 here and there. So this should be, hopefully, if done correctly, compilable. Yeah, okay. So this visualization should be the same visualization we had before. And again, guys, if you have any comments, questions, concerns, anything like that, feel free to let me know, and I'll try to address it as soon as I see it in chat. Right, should be the same visualization. Okay, so now, when this happens, I'm going to store the two indices. So we'll say moon theta of 1 is going to be equal to moon theta of 0. Okay, and we'll do earth theta as well. Is equal to earth theta here. Okay, so this should allow me to... actually, no, I want to do it the other way around. So I keep the earth theta here. And then at the very last... I need to think about this one. So this is going to be the earth theta. And then I'm going to have to find, let's see. We have the earth theta. And then we have the moon theta is just going to be down here. So I guess I'm going to say moon theta of 1 is going to be equal to moon theta of 0. Just so I know where these are. And moon theta of 0, I'm just going to reinitialize as m pi over 4. Okay, so what I was trying to do here, right? So let's bring up our visualization again. Oh, it's not up. Let's bring up our visualization again. So what I was trying to do here is I was trying to store two different thetas. One for the angle at which the Earth and Moon are now, and then another, which is the angle where the Earth and Moon is here and there. So I have a starting theta and an ending theta. Then I'm just going to draw an arc going from one Earth to the other Earth, and then one Moon to the other Moon. So that's why I have the arc thing in here. Okay, so let's go ahead and start drawing the line for the Earth, see if that works out, and then we'll go from there. So let me see, how does this make shared arc work? So I'm gonna go ahead and do std make, oh no, we'll call it auto earth arc. Okay, auto earth arc. I wrote arch because I'm so used to Arch Linux. Turd Yurt, thank you so much for following, really appreciate it. Okay, so we have earth arc, and this is gonna be equal to std make shared. Woohoo! I can type, I promise. Call it an arc. Now, what are these vectors? What are we looking at here? So it looks like world size x. So that's probably the origin is what we're looking at there. And then probably arc is going to be. I'm actually not sure what that is. So, vec 0 mpi. Okay, we're just gonna try something, and we're gonna see what happens. Oh, okay, I got it. I understand now. So the first argument is going to be the location, the center of the arc. The next one is going to be the radius of the arc, I think. And then the next one's going to be the initial theta of the arc. So let's try that out. Let's pretend we know what we're talking about. This is going to be sun location. What did I call it before? I think it's just sun loc. And then we're going to do earth location. And then the next one should just be a vec of 0, 0. Okay. And that should, in principle, work, I guess, if I get all of these guys correct. Okay, so now we have that arc. And now I'm just going to, I'm going to add an animator. So we're just going to say earth arc. And we're just going to add an animator to that. Okay. That's going to be a vector animator. And what are we going to do here? We're going to say it's going to go from whatever time we finished on, which should be 50 plus Gregorian year frames. And it will go to, let's do 100 plus Gregorian year frames. Ooh, that doesn't fit on a single line. Let's move that down to the next one. Oh well. 100 plus Gregorian year frames. Okay. Then we're going to do earth arc angles. Let's do earth arc pointing to angles. Add an ampersand in there. Change this to a minus sign because I'm an idiot. Mix up minus and equals. And we're just going to give the initial vector and the final vector. So it should be vec. I see. Okay, I'm understanding now. So it should be vec of m underscore pi over 4. And then it will be going to m underscore pi over 4. Okay. So that should be our initial vector. And then the final vector should be vec of m pi over 4. And then it should go, so let's just do this. Earth. Oh no. Earth theta. Theta of 0. Earth theta of 0. And then down here we'll do Earth theta of 0 and Earth theta of 1. Why am I so bad at this? Let's go. Bam. And this should be that there. That should, in principle, be our arc. Let's see. Renato, 1891. Thank you so much for following. If you were born in 1891, congratulations for living this old. Stay inside because the coronavirus will kill you. I'm sorry. That was a bad... I shouldn't have said that. But, like... I'm sorry. See you, Trash Talk. Thank you so much. I'm trying to get my sleep schedule back in shape. Have a wonderful evening. And, yeah. Hope to see you around next time. I will be doing... I can't stream this weekend. But I promise over the weekends I'm trying... It's a very lame promise. I'm trying to do better about doing streams that are easier for European audiences to watch. Sorry, I know this time zone's really bad for people in Europe. Okay. So we're going to add object, and then the last object we want to add is going to be world.add object We'll do world.add object, and then we're going to do Earth arc. Okay. And actually what I want to do is I want to add a layer, and we're going to add this to the top layer. Okay. This should in principle compile. That was running it. Should in principle compile. Boom, look at that compilation. And we're going to run it. To be honest, people should understand the importance of staying inside as much as possible. Yeah, I agree with that, but I shouldn't have said what I said. That was bad. I just wasn't thinking. So here we have the Earth and everything. Oh. Okay. Oh. See something going on. So we're looking over here. Keep going. Move forward, and the two Earths stop there. And then what is this line over here? Why is it all the way over there? That's the line I think I want over here. So why is it over there? Maybe because I'm an idiot and I don't understand what I'm doing. So let's see. World at size x times 0.5. World at size y times 0.5. World at size y times 0.25. I swore that would be the radius. Okay. So let's go from there. Earth arc is equal to the angles. Let me not add an animator. And let's just see what happens. So that means that this should be drawn. It should always be drawn. Okay, so there's no animator. This should always be drawn. Let's see what it looks like. Oh. Let's see what happens. I have no idea. I don't know what I'm doing. Gauss visualization. Crap. G++. That's just Gauss visualization. I've got a feeling this isn't going to show up at all. No, actually. Whereas it did show up before. Yeah, it's not going to show up at all. And the reason for that is because, I don't know. I'm giving it some random angles to draw over. And maybe that'll do something. Okay. And yes, so we have an arc. Do you see the arc? It's being drawn from here to there. This is not the correct arc. But it is an arc. There's something being drawn. Okay, so what do I need to do? I need to think about this a bit more. Because this is clearly there's something wrong here. I'm not sure what I'm trying to draw. So let me just change this from sun's location. Let's just change this to 100, 100, just to see what this does. Because I'm trying to figure out what that comment does. Oh, it should be vector of 100, 100. Okay. Run that and see what this turns out to be. Yeah, this is... Right, so there's our line. Yeah, it's 100, 100. So then if I put down the Earth... What? Why is the Earth location not okay? Let's look at the Earth location. The Earth location... Here's the moon location. The Earth location should be... It's the sun location. Oh. I see, because it's the sun location. So what we actually want is just the Earth radius. Right, we actually just want the Earth radius. Yeah, I gotcha. It should be the square root of the Earth radius times the Earth radius over 2. Let's just put this in there. And I guess we'll do... Should we have like an Earth offset, I guess? Yeah, let's just define that as well. So we'll just define up here. Vec Earth offset. Oh, man, can you guys hear them stomping upstairs? I feel like you should be able to. They're super loud. Is equal to this. Yeah, we'll just put this down here. That way I have it for later. Jeez, the whole house is shaking. Okay, so let's do DD here, and then we'll add Earth offset here. There. Okay, and then we'll do the same for the moon offset. Okay, it's going to be equal to this. I just can't wait to leave this house. Honestly, like I am super excited to just get out of Boston. Okay. And we'll put that there. And then we'll add the moon offset there. Okay. So D $ and moon offset. Okay. Add a semicolon in there. And let's add our thetas. Okay. So we have Earth arc is equal to this. And it should be sun location and then the Earth offset. Okay. Write that. And right. We should be able to do G++. And this should also give us Gauss visualization. Hopefully, this gives us an arc at the appropriate location. And then we just have to make sure the thetas are correct. And it's not quite correct, is it? It's slightly off. Why am I slightly off? The Earth offset should be... Yeah, how am I slightly off? The Earth location is just going to be the sun's location plus the Earth's offset. And the Earth's offset is a vector, which should just be the distance. Yeah, why is that slightly off? I have no idea. Let me see if the animation is at least correct. Even if the location is wrong, maybe the animation is fine. So we'll change this to 0, 0. And then we'll do G++. / Gauss visualization. Let's see what it does. Right. MPV. What is this guy doing right here? Why is it there? Darn. Okay. And it doesn't seem to be doing anything. It just moved. So it went from here to there. Also, what happened there? It looks like... No, okay, no, that's correct. It just moved. It moved to where it's supposed to move, but didn't animate. Oh, that's because I didn't give it an animate. Oh, it's freaking... Okay, so we're going to try that again, and then we'll see what happens. Gauss visualization. Move over here, and then we'll play it again. Let's see what it looks like. So probably the angle is correct, although admittedly, the fact that we have just a dot here is kind of weird. It is actually animating. It's just animating very slowly. That's not what I want either. Let's increase the animation here to be a bit shorter. It'll be just 10 frames. Let's do G++, Gauss visualization. Oh, I think I see what happened. Control C. I think this should just be 10. I don't think it's an animation from point A to point B. Where's our other animators? It is... Okay, let's see what happens. G++. / Gauss visualization. And let's just see what this looks like. I'm not sure, but I think maybe the second argument was a duration of the animation. Nope, that seemed to do nothing. Okay. Let's try it again. Grab this, put it here, change that to a 60. Try it again. And let's just see what it pops out. This is me relearning the Gauss VL library, by the way. I really should have learned it already. In fact, in some sense I have. I just can't tell if it's still animating or not. Also, that's clearly not an angle from radius 1 to the next radius, right? Like there's... okay. Okay, so there's multiple problems with this. First of all, the line isn't in the right place, which is kind of weird. And second of all, the arc is not nearly long enough. So I need to figure out why the arc isn't that long. So the Earth theta, what I want to do here is I'm just going to print it out. So std, cout, Earth theta, We'll just do Earth theta of 1. I guess it's fine. Should do. Okay, so we'll do G++. Gauss visualization. Why did it output? Okay. I understand now. If I is greater than lunar frames, how about we just say if I is equal to lunar frames plus 50. Let's do 51. Why not? G++, and then we're going to run Gauss visualization. That was me just being dumb because I was overwriting. Okay, so this should only output once. Gauss visualization. And I'm not seeing a single output, which says to me that this visualization is not going to work out. Okay, so we have this. And then it is not correct. Okay. Huh. So this line draws from... I don't understand why that's the line that's drawn at all. Lots of weird things going on here. So we'll say this goes from 50 to 80. It's going to be a 30 frame animation, so it'll be in half a second. And let's see, what do we have here? Why did this not output anything? G++ / Gauss visualization. It should output something, but it doesn't seem to be. Unless I'm just missing it. Let's just do theta is the optimal way to figure out if something's going wrong with the code. Gauss visualization. Right, I'm definitely not seeing anything in the trace there. Maybe I just put this into a file. Well, okay, this should still work. VI file. There is nothing in that file, which means nothing is being output, which means what? Which means what? That means the moon never stops. Why does the moon never stop? You're right, it doesn't. Okay. Right, so why are we not... Okay, that's super interesting. If we make this greater than... Let's go to this. Yeah, so that does it. The moon of Isosceles is a relatively stable orbit. So in this case, the moon will stop. Yep. Okay. So the moon never stops. What do you mean because it's a relatively stable orbit? I should be iterating through all frames from 52 Gregorian year frames, right? Here's a dumb question for you. Does friction exist between two opposing magnetic fields? I don't know. I mean, my naive answer to that would be yes. But just because if you send an object that you send through two competing magnetic fields will feel a retarding force that you can kind of count as some sort of friction, I suppose. I don't know. It kind of depends on how you define friction, you know? I don't really know the correct answer to that, and I don't really claim that I know anything about electromagnetism, so I feel like... I mean, of course, I studied electromagnetism in university, but I haven't done anything with it in a very long time. So I'm not going to sit here and pretend I know what I'm talking about there, you know? I should iterate through this value. If I is greater than lunar year frames plus 51, then at some point, it has to hit lunar year frames plus 51. It has to hit this value. But it never does. What? Why does this statement not catch? Let's see. If I is equal to lunar frames plus 51, I goes from 50 to Gregorian year frames. Lunar year frames should be in between Gregorian year frames. And in fact, it is, because at some point we're greater. Let's do lunar plus 51. And then we'll just output I. I don't know. I'm not going to put a new line on this one. I'm just outputting I. So we'll do G++. Lunar frames are... okay, right. Okay, Gauss visualization. Lunar frames are 660.581. Oh, I understand now. Right. Yep, I got it. I use floating point arithmetic because I wanted to be precise about it. But so let's do I is equal to the floor of lunar year frames plus 51. Okay. And now we're going to do G++ / Gauss visualization. And this should, theta is, right, so we have a theta. So this should do something of an appropriate animation. Yep, there we go. So we had an angle from one to the other. What I want to do is flip those angles and figure out some other things about this that are kind of weird. So we'll do, nope. So we'll start it on Earth theta 1. And we'll end it on Earth theta 0. Okay. And then the next thing I need to do is figure out why our arc is so far away from where we want it to go. Cruzux, thank you so much for following. Really appreciate it. Isn't that just heat loss through induction? Isn't loss of energy a concern in maglev systems, for example? Right. I don't know. I don't know about this so much. I probably should know more because, again, I have a physics PhD technically, but I don't really have an answer for you right now off the top of my head. I left my my physics books in OIST because I just didn't have room to carry them with me. Okay. So we have the sun location. We have the Earth offset. So what is this guy then? It looks like we have the arc correct. Like we have the angles correct. Hey Gibbous, how are you? But the line isn't at the appropriate location. So how do we get the line at the appropriate location? We have the Earth offset, which should be equal to... Yeah, it should just be the radius of the Earth, shouldn't it? Darn, what am I doing wrong? Maybe what I need to do is I need to do... I'm going to set at the incompetence and malice of governments, but what else is new? Yeah, I know that. I feel that. Can I do, like, norm? Do I have norm defined of this? Maybe I do. I probably don't, but maybe I do. So if I do vec of... Ooh, you there. If I do vec of this 0, this is my only guess. Yeah, I didn't think I had norm defined. So then let's do vec of, and let's give it a radius. So let's do Earth radius 0. My guess is that API wise, this takes in a different value. Okay. Right, so we have the appropriate theta. Let's do the MPV command. It's broken. Crap. Yeah, I completely broke it. Change this to a 1. G++. Gauss visualization. Let's see what this one looks like. MPV. Okay. 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 I was wrong. Hey, Barry10, how are you? Thanks for following. Really appreciate it. Okay. I need to figure out what this arc is. So it's world size y dot 0.25, world size y dot 0.25. So what if I just do Earth radius twice? I don't exactly know what this will do. I'm just making stuff up. Gauss visualization. Okay. Now let's do a visualization here. Let's see what we got. MPV. That almost looks like the right location. Nice. Okay. Cool. So we have the right location. Good. I don't know exactly why we're at the right location, but we have the right location. So let's just do stuff. Does this fit on one line? Please fit on one line. Dang it, it doesn't. Oh, but that's okay. This other vector can go here. And the initial arc is going to be... let's do... world.add object here. World.update. Can I only add object if we're over a particular frame? So let's do dd here, and we'll say if... what am I looking for here? If I is greater than... and when do I want to start drawing this? I want to start drawing it at 50 plus Gregorian year frames. Year frames. Something like this. We will add the object then. Let's go here. And we're going to add, what object do I want to add? I want to add Earth arc. Something like that. And then the actual angle I want to give Earth arc is just from Earth. Ooh, let's spell Earth right. Earth theta 0. Earth theta 0. Okay. So one thing I've just realized with GaussVL, I think, is that we can only draw arcs one direction, but let's just see what happens. So G++, Gauss visualization. Take a look at the visualization after that, and we'll see what we have. And again, guys, if you have any comments, questions, concerns, ideas, anything you want to talk about, feel free to leave it in the chat. I realize chat's a bit quiet today. That's cool. Sometimes we're a bit quiet. Sometimes we're not. But again, no pressure to talk if you don't want to talk. MPV and right. So we don't have the arc, and the arc should appear right now. Okay. Right. Almost what I wanted. You know, it's the opposite animation of what I wanted. But hey, you know, you have to start somewhere. So let's just try. What? Why did the arc? So the arc drew from Earth theta 0 to Earth theta 0, where Earth theta 0 is going to be pi over 4, right? So what if I just make this 0, 0 again? Okay. We'll do G++. Gauss visualization. And let's see what we got. Also, I want to delete that comment. Yep. Okay. And then once this is out, hopefully we have that arc drawn. And then we just have to draw the next arc, which is going to be... see. What's going on here? Why did we draw... See, this there? Why does the whole circle just appear? Like, under what situation would I want the entire circle to just appear like that? I know this is my fault for just being crappy at programming, but, yeah, let's just move this up here while we try to think about what's going on. Okay. Right, so we have the sun location and the Earth radius. That's cool. We have vector 0, 0, and then it's being drawn from... Okay, I think I'm starting to see the problem. We need to draw it from... Okay, can I just try? I'm just trying stuff right now. I'm just really bad at this. So let's do vector of this guy. Okay. That added a new line because I'm bad at spacing. Compile this guy, and let's see what it looks like. Okay. Yep. I realize the movie's being redrawn. Give it a second. Yeah, I should probably lower the resolution of the frame as well, but it's fine. I'll just let it do its thing. Okay. Check this out. Nope. Okay, wait. Okay. And right. Still does it wrong. What happens? What does up and down do? Right. So someone mentioned. That's not what I want. Okay, let's keep going. We have the arc. It's kind of drawing, but for some reason it's not drawing the way we want it to. Let's go back to what was working. Kind of. Let's just do 0, 0. And down here we'll change this to 0, 0, 0, 1. And I think I'm just going to go ahead and put in the moon arc as well. And then I'm just going to try to debug this off stream is probably what's going to happen. So we just have both arcs there. They're both going to be wrong, but we'll have both arcs there. And then we'll just see. Wait, did that work? How did that? There's no way that was too quick. Huh. Okay, so we have these guys and right. So the arc just goes in the opposite direction of what we want. So here we have this, and then it goes from there to there. And I wanted it to go the other way. Fine, fair enough. We have something that's kind of working. I need to increase the line width somehow, but that's fine. So now we're going to do the same thing, but drawing the lines, the line for the moon. So let's do yank 10, yank, and we're just going to paste it down here. And we're just going to, do the same for the moon. So let's look for Earth. Okay. And here we're going to do moon radius and the moon radius here. And we're going to change this to the Earth location. Okay. Remove a few spaces there and there. Removed one too many spaces there and there. Earth again. Change this to moon. This is going to go from 80 plus Gregorian year frames to, let's make it 90. And we'll do 120. Why not? Okay. We'll change this to moon. And change all these guys as well. And this should give us a moon theta. Here, there, and there. Write that. And now let's update the world here. So we'll do yank 3 yank. Paste it down here. And we'll do world.add object, and this will be the moon arc. Write this, go to G++ / Gauss visualization. And right, we'll just see what happens. So, yeah, man, chat's super quiet today, but that's okay. It's sometimes good to have quiet days. So we'll let this go. What? What? Okay, so here we have these guys doing. We have the Earth arc being drawn, and then the moon arc is just going crazy. What on earth? Okay. Is this because... Why is this? Right. Moon arc here. So we've auto moon arc is SDE make sure it arc, Earth location, and then we have the moon radius. Fine. Moon arc angles. I can try, changing the thetas. Oh, also I put this in the wrong spot. That might be part of the reason. So it's going to be greater than 90. Okay. And let's just do G++. Gauss visualization and see what we got. Right. And then once this is done, I think we'll have kind of sort of a visualization that we're looking for. I think it's a good enough visualization for the next video. and then we'll go from there. Yeah, this video is taking way longer to. I feel like I know I did something wrong when it takes forever to render, and I don't know exactly how GathVL knows I did something wrong. It knows, and it's punishing me with longer compile time. That's exactly what's happening here, or runtime, I guess is what this is. Oh well, we'll see. But yeah, guys, like I was saying before, I do genuinely want to put out more YouTube content. I know it's been a while, but I think I'm going to try to put out more content. Might be different style. I just want to try, see what happens. I know at the start of this year, I was kind of sort of against doing a lot of YouTube videos and stuff like that. But I've kind of changed my mind. I feel like, you know, my largest audience is on YouTube, and I think it's fair to put out more content there. How is this taking so long? It's literally 10 times as long as the last run. Okay, well, get some water, and we'll just let it do its thing. Okay, maybe you can only draw one direction, and so it's... Oh, sorry, my bad. There it is, MPV. Let's see. Here we have this guy. We have one arc being drawn, and then the other arc is not correct. Whatever that is, it's wrong. I watched you simulating quantum systems today and loved it. Hey, I'm really glad. Right, I promise I'll be putting out more content. This is for my next video. It hopefully will be coming out this weekend. I just have to get all this arc stuff figured out. But we're kind of almost there in a way. I just have to figure out... I have to figure out some other stuff. And I don't know what that other stuff is that I need to figure out. So I'll put this up here in the corner. But yeah, I genuinely will be putting out more content as soon as I can. I think it's a good thing to do. So here we have, let's see, so we have the Earth going around. It stops right here. We draw one arc, and then a circle just appears. Because a circle just feels like appearing. But this should be drawn between 90 plus Gregorian year frames to 100. We should be updating the moon arc angles with moon theta. What is moon theta not? Let's just output that really quick. Or moon theta 1. STD, C out, moon theta. And let's just output moon theta of, what am I looking for? 1. New line. Write this, go here, G++, Gauss visualization. Okay, and moon theta is negative 83.438. But I don't know what that means, but probably that's why it's so crazy. Okay, I understand now. So we want to do moon theta is equal to moon theta 0. What? What was our previous guy? Let's see. We were outputting this theta is message, but I don't know where it is anymore. It's probably up here somewhere, right? That's a lot of them. So theta is what? Should be on its own line. Theta is negative 5.36146. So let me just do... can I just... Is there an F mod? There probably is an F mod. So let's just do this. Why is the moon theta so high? But the... Let's just do an F mod here. And let's just do F mod. I hope F mod exists in C++. And 2 times m underscore pi. I'm going to guess that's the reason. Control. Yeah, that's probably why it's taking so long. Yeah, I bet you that's it. Has to be, right? So probably it's just drawing a bunch of arcs, and that's probably the issue. So if we do G++, I hope Fmod exists. It seems to. Gauss visualization. Moon theta is negative 1.78, and this should take phenomenally less time. Where is it? There. Okay. So we will MPV. Let it go. Okay, that's not bad. That really is not bad. The arc is a bit long, but we do have an arc from one theta to from one to the next. So we have one arc there and one arc there. I want to change the colors and do a few more things, but I think this is okay. What we have right now is okay. So let's go ahead and DD here. What do I want to do? Earth indices is here, and I'm also going to do an F mod here. Just because I feel like doing an F mod. 2 times m underscore pi. Right, that should do it. I'm going to run it one more time just to make sure it compiles. And I think that'll be it for now. So we have something that's good and debuggable. We have one more visualization we have to do, and that should be it for today's stream. Let's go get status. Give clear. No one look at that. Git commit. Status dot git add. Gauss visualization dot cpp. Git commit. Dash m. Adding arcs to show difference in I guess lunar and earthly precessions. I don't know. Okay. Git push. Origin master. So it should be available on Simuleos right now on the GitHub directory. And I think that is it for now. If you guys have any questions, feel free to ask now. This is kind of the end of stream. And if there's somebody that you want me to raid at the end of stream, feel free to let me know. We've got Poku doing art. Lana Lux, science and technology. Loading artist, again, doing art. I feel like I follow a lot of artists. Anthony writes code, but playing Pokemon Sword and Shield. Callow Creation, CM Griffing. Lots of people live if you want to raid someone. I kind of feel, I don't know. Are you guys up for an art stream? Maybe you're not. Maybe you guys want to do more of a programming stream. If you want to do that, we can do CM Griffing again. But I feel like I did CM Griffing just recently. Like I feel like I did him yesterday or something like that. Skylease is just chatting. We could talk about space. What do you guys think? If you guys have someone in particular you want to raid, feel free to let me know. Otherwise, I might just do Poku. I like Poku's stream. She's a cool artist doing some Clinic of Horror stuff. Pretty cool. Let me know. And of course, if you guys have any questions, comments, concerns, anything like that, feel free to let me know as well. Before ending the stream, I guess I'll end the stream the way I started it, just chatting a bit about not really coronavirus issues, but I guess my point is I do genuinely want to start putting out more content. It's been a while, and I feel like it's been too long, you know? I have an opportunity here. We have an opportunity as a community to do some really cool stuff, and I kind of want to just capitalize on that. So I think what I'll be doing more often from now on is I'll be making more videos, some of which are not related to the algorithm archive, some of which are just videos I want to make and see if they stick, you know? This might mean I lose subscribers in the short term, but I feel in the long term it's better to just put out stuff that you like, even if it's not necessarily what people are used to, you know, this type of thing. I'm not gonna like radically change my content. I'm not gonna like talk about like I'm not gonna do gaming content all of a sudden, but we might do something kind of fun. Like for example, we have this Vim cube thing. I might change this so it's VI cubed, because why not? I don't know, lots of things like that. I want to do a video on the Arch install speedrun that we did a long time ago. So many cool things I want to do. I figure a vibrant community of people who just like to hang out and chat and enjoy themselves is a vibrant community, and I think it's good to you know, bring that community along wherever you go. You know, always get here late. Sorry, Frumsy. Right. So I think that's where we will stop for now. Like you really do be vibing though. Okay, I kind of want to raid Pokori Mew. She's just a really cool art streamer. I'm gonna be honest. She technically wise, right? It's not a programming stream, right? But she's got a really cool vibe. I really like her. She's cool. She's just nice, chill, and everything like that. So I think that's what we'll do. I really appreciate it. Thank you guys so much for coming in. And let's go ahead and start the raid on Pokurimio. Nice. Okay, guys. Thank you so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens of your time. Tomorrow we'll come back, hopefully get all the visualizations ready so we can put it into the algorithm archive, actually put forward the PR for the algorithm archive. So this means we'll be reading through the content, making sure it makes sense, finishing up one final visualization, and that should be about it. I think we can do it all next stream. hopefully you'll join me there. The stream after that will be finishing up some video stuff. Hopefully I'll be able to do video editing on stream on Friday. Might sound a bit boring, but I'm pretty excited to do it. So we'll see how that goes. Thanks again, guys. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. I'll see you guys around next time for the next episode of Simulators. Bye, guys.